So in this circuit, we want to determine the voltage gain. So the voltage gain is given by the equation RC. This is a small c divided by RE prime. Okay, RE prime is given by 25 millivolts divided by the DC emitter current. So to solve for the DC emitter current, we need to solve first for the voltage here at this point. Okay, so that we can solve for the emitter current, which is passing through the emitter resistor. So our approach here would be to use the Thevenin equivalent resistance or Thevenin equivalent circuit for the voltage divider circuit. It's always a safe approach because you don't have to think about whether the input base resistance is comparable to the other parallel resistors. So just to be safe, you can simply use the Thevenin equivalent resistance to solve for the bias. Okay, so let's begin with the Thevenin resistance. Thevenin resistance is just given by R1 over R1 times R2 over R1 plus R2. So R1 we know to be 47 kilo ohms and R2 is 12 kilo ohms. So divided by 47 kilo ohms plus 12 kilo ohms. Okay, this gives us a value of 9.56 kilo ohms. Okay, VTH is given by R2 over R1 plus R2 times VCC. Now R2 is 12 kilo ohms and R1 is 47 kilo ohms plus 12 kilo ohms times VCC, which is 18 volts. So here we have 3.67 volts. Now IE is equal to VTH minus VBE over RE plus the Thevenin resistance divided by beta DC. We know VTH to be 3.67 volts. We also know VBE, which is 0.7 volts. RE is 1 kilo ohm. RTH is 9.56 kilo ohms divided by beta DC, which is 75. Okay, so solving for that, this gives us 2.6 milliamperes for the emitter current. Okay, now we can get RE prime. So RE prime is 25 millivolts divided by 2.6 milliamperes, and the value is 9.49 ohms. Okay, so now that we know that, we can now solve for RC. This is small c, and this RC is the equivalent resistance of this and the load resistance, because at this point the AC voltage sees this resistance and this resistance. So RC is just the parallel equivalent of RC and RL. Okay, and this RC is 3.3 kilo ohms. RL is 10 kilo ohms. So solving for that, we have 2.48 kilo ohms. Okay, finally, we can get the voltage gain, and the voltage gain is nothing but R so small c 2.48 kilo ohms divided by RE, which we already know as 9.49 ohms. So this gives us a voltage gain of 261. Okay, we can also solve for the voltage gain from the source, but for that we will be needing the RS, the source resistance. Okay, and also we need to compute for the input total input voltage, total input resistance. Okay, since we don't know what RS is, it's not given here. Okay, then we're not able to solve for the gain or the attenuation from the input down to here. So we're only able to solve for the gain from this point uh, to uh, to this point here. Okay, and that's what this 261 means.